final part of this entire business of the manner in which the earthworms go about plugging their burrows. This is a closer shot of a burrow from where the leaf has been excavated out. So, you can see the wetness of the leaf that probably had been inside is pulled out to just show the burrow in which the leaf had been buried. Now, that is another shot to show you once again the leaves buried maybe 1/3 of its way inside or whatever, and that is it. Darwin was interested in the manner in which the worms plug the burrows. Is this necessarily a very important, interesting issue that you should now engage in? I am saying you. Do you think it is a very important stuff to be sort of working on? Probably yes, probably not, depending on the perspective, but for Darwin it sort of caught his imagination and he decided no, this is a very important issue. So, let us see that in some detail. Now, we are switching from Darwin to our own sort of artifactual construction. You have a cylinder, open cylinder, and the task before us is to now drag a leaf or a sheet of paper through the cylinder. Let us say I have a structure such as that. I need to not push it in, because earthworms do not push, they drag. Remember the earthworm, if you have to sort of imagine the burrows there, the earthworm cannot go head down. So, it has to go and then sort of pull the stuff, and then head down it should sort of slide into the burrow. So, whatever it is sort of plugging, it has to be done by the pulling rather than by pushing, right. Now, I have a cylinder here which you see in the slide, and I have a full sheet of paper. I like you to sort of try and see how you can get this paper inside the cylinder, and this is your mouth part. This earthworm uses the mouth part to hold and then pull. So, you have to pull the sheet of paper into the earthworm burrow. Would any of you volunteer? So, there you go. Now, as you are doing, you please realize what a Herculean task it would be for the earthworm to be doing that. It's difficult. Okay, fine. Let someone else try.
It's difficult for everyone.
Except that you should not mutilate the paper. You can't roll it up as a BD or whatever it is, but it has to now go in. Wow, let us clap to her. Good, great, very fantastic, fantastic. What is your name?
Srishti.
Srishti. Would anyone of you like to do this before I ask her the question? Can anyone else try? You are a successful earthworm. Wow, what is your name?
Ron.
Ron. Now, both of you did a very deliberate action. I will tell you what the deliberate action is, right. Give me the paper if you can. Both of you sort of held your mouth part
Very close to the paper.
to the apex,
Yes.
to one of the angles of the one of the four corners of the paper. Okay. That is a very deliberate one, that you never even thought of putting the forceps on any other part of the paper. That means you really thought, correct, quote unquote, of the best possible solution for the problem. Yes or no? I mean, involuntarily you would have, so that cognition would have gone through your mind in whatever time scale. Now, let us say we therefore look at this example. So, option 1 would be to pull the paper by its longer axis. Option 2, whether you do it or not, to exhaust the global options available would be to do it by the shorter axis. And so, if you now ask this question, which of the two will be the most preferred option and why? What would be the most preferred option between the two? Option 1 or option 2?
Option 1.
Option 1. All of you agree with that? Option 1. Right? Option 1. And why could that be the preferred option rather than the second option?
Because the surface area is smaller for it to drag in, hence lesser force will be required to pull in.
Okay. Because of least resistance. So, as I now pull this leaf through, if I were to do it by the longer axis, as I now pull in, the leaf is going to fold, the paper is going to fold on itself and your resistance is gone away. If I did this with this axis, which is the sort of shorter axis, if you now talk about this one, when you try pulling in, it will go, but then what would happen is, it would after a certain while refuse to go inside, and effectively the burrow is not going to be completely closed. So, you would have ineffective closure of the burrow and large portions of the burrow will be left open. Is that right? So, good. If we did a thought experiment, the same experiment, but our experimental subjects now are going to be not you, but kids, 3rd, 4th, 5th standard children. You are likely to get a little messy result. Some kid would now sort of do here, do here, do here and all that. You agree to that? It is just a thought experiment, I have not done it, but I am expecting that would be the sort of reasonable results you would get. But if you did it with adults like you and who have already been explained off the entire issue, now you zoom on to it absolutely without waste of time and say option 1 is the best one. Clearly, all of you are guided by some degree of intelligence, which drove you to now do the pulling the way that you did. How on earth do the earthworms do, who apparently we do not sort of concede that they are as cognitively capable as you and Ron? How on earth earthworms do it? Darwin decided the best way to go about answering this question is, what way? Just go to the burrows, pull out the leaves and find out how many of the leaves have been dragged by the longer axis, how many of them have been drawn by their shorter axis, and do a small analysis. And as all of you know now, Darwin has been a very great observer. If you read his book on Origin and a few others, he goes to great extent to make very, very, very precise observations on the material that he went about studying. So, he went about doing this. You have all those leaves littered on this ground there. So, he decided, okay, there is a polarity to all leaves, longer and shorter and so on and so forth. He nomenclatured them as the tip or top of the leaf, bottom, and then you have middle portion, and got hold of 227 leaves from the burrows. He sort of pulled them off the burrows and asked what is the axis with which the earthworms had pulled the leaf into the burrows, and that is the graph. He works out the percentage and finds that 80% of the 227 leaves were pulled by the longer axis, and the rest few percentage is now distributed between the base and the middle. So, if you were to do a chi-square, all of you know a chi-square analysis, which in fact I did, I am not showing you here, Darwin did not do, but you will find a very highly significant chi-square indicating that the earthworms are pulling the leaves in a non-random manner, where the earthworms are pulling the leaf more than is expected by sheer chance by their apical end rather than by their basal end. So, Darwin concluded this observation alone is sufficient to show that chance does not determine the manner in which leaves are dragged into the burrows. Please remember, if you had done this experiment with school kids, you would have found lots of messy data here. It would not be as clear as what is shown by the earthworms. So, that means according to Darwin, they are not chancy in the way they pull leaves into the burrows. They seem to have a certain degree of cognition, what you and he employed in pulling the leaves through the cylinder. Now, Darwin decided it is now time to ask something more rigorous than just the observation that he did on existing leaves in burrows. Can we now devise some experiment, and can we now show what the real behavioral predispositions are with these earthworms to engage in such a observation. The few experiments that you are going to be witnessing now are, I would say, in the best traditions of scientific rigor and protocol that any modern scientific lab would be undertaking, and this is in the years between 1837 and 1881. One of the trees that lined up the place that he was studying his earthworms was a tree called lime tree, whose leaf structure is that. You have in this leaf a distinct apical end and a distal bottom end, and one thing that you see in this leaf is that the apical end being more acuminate than the basal end. Incidentally, this is one of the most commonest leaf morphology that you will see in plants. For example, this is a plant Polyelthia, I think, where this is the apical end, this is the distal end or bottom axis. What you see is acute apical end and obtuse or broader basal end. Now, those are variations of the same sort of structure, where you have an acute apical end and a broader basal end. From the path of least resistance, which is a path it should now move the leaf into, which part? The apical end. So, what he did was he got 70 leaves and found out what is the frequency with which the leaves are taken in, and he finds about close to about 80% of the leaves of this sort are pulled this way into the burrows. It is a no brainer now, because this gives you the least resistance. So, as you pull it into a burrow, sort of it closes the burrow snugly, correct. Leaf morphology are not always this, there is a certain amount of difference in leaf morphology, and there is a particular plant called laburnum. The property of this leaf or plants of this type is that they have a leaf structure of that sort, where if you fold the leaf halfway on each other, you can barely make out which is the apical end, which is the basal end, because their angle of acuity or whatever you call that angle is the same for the basal end and for the apical end. Remember the mind of Darwin working. He wants to ask this question, how is it that the earthworms are able to move on to the apical end? First of all, he established that. Now he is asking how. So, he is constructing experiments with a variation of theme of trying to select from nature leaf that are having similar angles, and this plant has got similar angle both at the apical end and basal end. So, this 3-leaved stuff, you can pinch it off, they fall off into the ground. What is the expectation here if these leaves are offered to earthworms in terms of polarity of them being pulled into the burrows?
Basal tip should be equal.
Basal or apical end should be, they should be equally likely. Okay? Very simple. So, that is what he expected. I am not putting his words there. And when you actually make the observation, you find that nearly 70% of them are taken in from their apical end, despite the fact that the two halves are mirror images, and the frequencies are slightly more in the bottom compared to a previous experiment, but thereabouts, nothing more. Still, if you do a chi-square for this data, you turn out it turns out it is significant in favor of the apical end, which is in fact not what you would expect if only the angles were to matter. Okay. So, Darwin asked why are fewer proportion taken in by the base when it is no different from the tip. This sentence is not mine. All the sentences that come up now are Darwin, which I forgot to put the quotation mark. So, these are Darwin sentences. Why are fewer proportion taken in by the base when it is no different from the tip? This is a most common morphology of leaves across. If 85-90% of the plant species in the area that he was working had this type, and if earthworms knew that for some reason whichever there is a petiolar end is broader and that is narrower, they would tend to sort of feel the petiole or whatever it is and know that that is going to be broader, so I am not going to touch it. Though in this species laburnum it happens to be that even the petiolar end is as narrow as the apical end. So, there is some sort of a historic habituation, the contingencies of the species frequencies are sort of ingrained in the knowledge of the earthworm behavioral dynamics. Okay. Now comes a piece of cake. Biology is very fascinating. Why? Because of the diversity, the huge numbers of diversity, whether you talk about molecular cascades, gross phenology and so on and so forth. Here is, can you guess what species of plant this is? It is this wonderful plant called rhododendron, which are there in the country in the Himalayas, one species there in the Nilgiris, and these rhododendrons have a fascinating leaf morphology. This is not a rhododendron. This is picked up from in front of your ICER guest house. I call it the phylogenetic tree. This is actually equivalent of a botanical equivalent of a phylogenetic tree. So, there are clades and all that stuff. In fact, I use this in some of my classes to talk about to construct phylogenetic trees. But what do you see here? The apical end is blunt, the petiolar end is narrow, okay? And from the previous slide, what did Darwin say from this previous slide? That the earthworms are not going to the basal end despite the basal end being as acute as the apical end, probably because the earthworms have known to associate the petiole with the broader end, and so if a petiole is there, no, I am not going there, right. On the same count, these sort of leaves, what should be the expectation if what is shown here is true? If you offer rhododendron leaves to these earthworms, what would they do? Petiole end, don't touch, right. Go and get the apical end, however broad it is, as broad as a spade also. I mean, we are going by sheer logic. See, I am trying to emphasize to you, besides the work, I am trying to go into the mind of Darwin, how that has been working, and that is exactly what has been done, and he describes in his book. So, if this is it, my expectation or Darwin's expectation at that time was, look, based on this experiment, I would expect the earthworms to mess up, take here and not take there.
Isn't in all these experiments, aren't you assuming that there is a success rate the first time it pulls it in? I mean,
okay, your question might be preempting something that I am going to be telling, but anyway, I would like to sort of address that. So, Darwin was seized of this question that you raised, and he went about asking if these guys actually do a trial and error business, you know, put all the paper or whatever it is in all sorts of manner, and by default what works.
Yes, it is quite intuitive that whichever offers least resistance they would try.
Yeah, that another question to that is that you are supposing that the earthworms have tried all permutations before getting at one that works, and in fact they do not need to exhaust all permutations. If let us say on the first try this goes in, fine, then if it does not go in, they turn, and then you know, and then finally something goes in. Now, is that what earthworms do? And that is your question. Darwin went about, not at this time, but few experiments later actually trying to ask that question to see if they do. I will tell you the answer if you wait for a few minutes more. And so anyway, coming back to this, look at the results of rhododendron. It has, as I mentioned, a broad front end, a narrow back end, this leaf, and there you go. What happens if it is not percolated in mind? These guys now know that this is the one to take it in through and not this one. And this experiment shows, therefore, for some reason, that the petiole is not the stuff that is giving a cue to the earthworms of saying do not take that, because that is most going to be the broader end. But if you really give them a leaf of this sort, they would rather take the leaf in through here than through here. So, that was a fantastic experiment to do and think about. And what does Darwin say about it? He says the worms judged with a considerable degree of correctness how best to draw the withered leaves of this foreign plant into their burrows, notwithstanding that they had to depart from their usual habit of avoiding the food stalk. Does it sink in you, the gravity of this entire experiment? These experiments, mind you, they are no match to today's PhD experiments. They are so elegantly planned in their thought construction, in their execution, in their analysis. It puts to shame if we can't do anything better than what Darwin did. That is what I would as a teacher say. Now, pine, unfortunately I do not have a sample of pine with me, but those of you who have seen pine needles, you have the needles like that, right? They are forked. I have a concocted version of pine, it is not pine, kept it carefully in my pocket. So, what you see there is they are the needles, they are stuck at the upper end, that is this is the end to which it is stuck to the plant, and so you have the two needles, right. So, those two needles coming out of a common origin, and when the needles fall off, if that is the only material available for the earthworms to pack or plug their burrows, how do the earthworms do it? It's a very difficult question, like your cat questions. If I pull it this way, one thing will be there, one thing will be here, and remember it is not going to plug it in, right. So, should it do it this way? If it does that way, the entire thing goes in, right. So, for some reason, though this is more sort of sharper end than this end, they should now decide not to go in for the sharper end, pointed end, rather go to this end, despite the fact it is more blunter than the apical end. So, let us see what happens. In this experiment, 97% of the trials that he provided, the earthworms picked unambiguously this part of the needle and pulled it in. They refused, they did not do it on either of the apical end. What a wonderful observation. Then it asked, would this overwhelming evidence or overwhelming preference for this end of the pine needles be due to the fact that they are in some way conjoined, and therefore, can we now sort of see if we join these two ends, what would happen? Now, before that, almost all pine leaves were pulled out by the petiole end, and what Darwin says is, in order therefore that worms should do their work well, they must drag pine leaves into their burrows by their bases where the two needles are conjoined, but how they are guided in this work is a perplexing question. That is the sort of needle you can see there. So, they are only doing it from the basal end, they are not picking from the apical end at all. So, what it did was, as only Darwin can do, he decided that if I fuse these two ends by shellac or by tying it with a thread. So, first he did with shellac. So, your real basal end and the apical end were no different, and let us look at that. When you do that, they still prefer the basal end and not the apical end. Now, he told something must be wrong surely, because there is nothing, no difference in terms of whatever polarity if you know sort of fuse them up. But is the shellac in some way repelling the earthworms? So, what this guy did was he actually did what Mohan did for me. He tied the other end by small thread, which is not going to be deterring the earthworms, not going to give the smell of shellac or whatever it is. And he did that, and when he did that, lo and behold, the data did not change. So, shellac or no shellac, if whether you fuse or no, they seem to be sort of knowing which sort of position to pull them in, and this therefore made him infer that it is not the divergence of the two needles which leads worms in a state of nature almost invariably to drag pine leaves into the burrows by the base. There must be something attractive to worms in the base. If the earthworms have dealt with pine needles, they probably have queued on to the resin which is here and not here, that probably makes them go on to the queue of pulling pine this way, because you do not get pines this way, right, in nature. So, they aren't going to be responding how much you try your best to fool the earthworms. Their queues are already laden in the basal end of the needles. The sum up, he says, as chance does not determine the manner in which objects are drawn into the burrows, and as the existence of specialized instincts for each particular case cannot be admitted, the first and most natural supposition is that worms try all methods until they succeed, as you mentioned, but many appearances are opposed to such a supposition. That red sentence indicates he went through this and he decided to do very precise experiments to see if they actually do a gymnastic in the night. Actually, when do they close? I forgot to tell you. By the way, the behavior of earthworms is they are nocturnal, they come out in the evening and they close the burrows just at dawn when they sleep over the day. And so, what Darwin and his son Francis was doing this experiment, much of the experiments together with Darwin. So, what they would do is they would now shine light in the night and see whether these earthworms actually sort of do the trial and error, and invariably they found that they never seem to be sort of fiddling around, they just would home on to the end that they want to pull in. And so, there seems to be some sort of logic that these guys are now made up with that tells them which is the part to keep their anterior portion and then pull in. Now, I come to the last final experiment. Incidentally, Darwin did a set of 17 experiments. I am not giving you all of them. I am now zipping up to the last, and I would say one of the most momentous experiments that Darwin did. Yeah, please.
So, if it is just sheer logic by which they kind of sense which end would rather offer least resistance,
right,
it does not explain why when you have leaves where the apical and the basal end both have the same angle, still the preference remains apical and not basal.
You are very right. So, what he now says is that if you overlay on that certain cues that these earthworms have already learnt to be using, they would rather go on. It is, in the case of behavioral sort of should I use the word ecology. Now, there are layers of information that you build on based on what the relative costs of acquiring those information are. If a cue of gum in the case of pine needles is the most overriding cue that can tell me which is the polarity, I would rather do that rather than struggle and all that stuff. And in foraging theory, this is something very common. You have what is called as a global search, and then you have a local search. Now, global search approximates what you want to search, whereas local search intensifies the search in a certain area where you are sure that stuff what you are looking for is there. So, these earthworms might be using layers of strategy and not only this strategy of what we say hit and try, number one. Number two, which I will probably, that is the last point I would like to make from this experiment, answers one more, that it might not be as dumb as you and I believe it to be. So, let me now reserve that for another 2-3 minutes away. Yeah, I am sorry.
So, if in a patch you
Yeah.
provide the earthworms with all the sort of morphologies,
Right.
so then are they choosing which leaves they pick? Is there a
That is a very interesting question. Darwin did attempt to answer this question by that first experiment of 227, which he found. But it so happens that there were only 3 or 4 species, the lime tree being one of them, and among them he found that all of these leaves are being used without any distinct manner segregating them into this or that. Also, maybe I would like to mention this. This is another second layer of information. Now, the earthworms are actually not hunting for leaves. They take the leaves whichever is around, whichever is closest next to their burrow. They do not really crawl for meters together. So, whatever is in the vicinity, they sort of plug it in. So, that way there is no preference on deliberately sampling and bringing only the leaf that is most desired otherwise.
So, among the 17 experiments you said Darwin conducted on
Yeah.
earthworms, did he try one experiment where he has all the 3 types of leaves together and earthworms choosing one of them?
No, he did not do that. He did not do that, yes, clearly. That is, he offers this leaf to all the 3, in the vicinity, and
Yeah.
that is a wonderful thing.
Just to see if
Absolutely, absolutely. Okay, the final experiment is an experiment where he decided, no, let me not try, because all this, the business of Q, this and that is going to come in, the petular end, this and let me sort of do an aseptic experiment. That is why I told it is a momentous one. So, now you told all this, and also the earthworms getting used to a certain leaf, foreign leaf, alien leaf, native leaf and all that stuff. Now, no such thing and no botanical morphological differences. So, he picked up cardboard pieces, thin cardboard pieces to mimic leaves. So, he cleaned this area of the leaves, the litter, everything is removed, and he created these cardboards of 2 types. I wish he had done what you mentioned in terms of all the 3, but anyway. So, you have a cardboard which has a broader angle and this cardboard which has a narrower angle, triangles of certain dimension. All these are accurately measured, I am not going to the details of that. So, you have an apical end, middle and basal end. What he did is, and I would say this is grand hypothesis. Believe me, when I first read this, I was bowled over, because it is something that even today many practicing scientists do not necessarily do their science in the manner that is put across here. So, the first statement of purpose of his experiment he mentioned was, and these are his words, if worms seized indifferently by chance any part, they would assuredly seize on the basal part or division far oftener than on either of the 2 other divisions of triangles. We are not talking about leaves anymore, we are talking about these. If these triangles were offered to the earthworms, and of course, it is assumed that earthworms will take in. So, what he did before going into all this elaborate planning of his experiments with, what is the use if the earthworms simply say, no, I am not going to take. So, he made sure that these earthworms actually take, wax he does a little bit of animal fat on it. So, softens this cardboard and these cardboards are taken in by the earthworms. So, he knows that the earthworms can or will take in the triangle. So, what he is saying is the broader end, this yellow, will be more frequently taken in by that side than the middle, and in fact the apical end would be taken least if it is only a random machine doing it, simply because of few reasons. What are the reasons? this is his expectation, that if the earthworms were behaving by simple chance, they would pick up the yellow region more frequently than they were picking up the middle region, and least frequently and at the very top. Why would Darwin make such a
Chance
hypothesis?
of encounter increase because of the size. So
Very good. So, he explicitly went about stating that. So, but why? Why would he say that? Look at the details of his analysis or analytical mind working. A, the area of the basal region, this yellow region to that white region, is 5:1 in a triangle. If the earthworms were taking in the cardboard by suction, so they suck their mouth part onto the basal end, either up and up top or bottom end, they are going to do it 5 times more frequently if they were to encounter the basal end compared to the apical end. So, your frequencies of selection of how they are pulled in will be 5 times to 1 in favor of the basal to the upper end. Clear? Second, if they were picking by the angles as you both did, the base offers 2 angles whereas the apex only 1. So, by sheer pulling from the angles, the earthworms are expected to pull twice or as more frequently from the basal angle than from the apical angle, because there are 2 bases to 1 apical angle, 2 angles at the base to 1 angle at the apex. If they are going to do it by the perimeter, they will be doing it 3 to 2 for the broad triangles and 2.5 to 2 for the narrow triangles, simply of the construct of the triangle. You can measure the perimeter and work out in that ratio, and even there you have your basal end being preferred over the apical end if the earthworms are doing it by chance alone. Can you now beat this experiment in its construct, in its sort of exhaustiveness in terms of the variables he has dealt with? So, he proposes this, and what does he do next? He offers a certain number of triangles to the earthworms and asks the earthworm to do the job. These guys, his son and he, they go to the field the next day and retrieve 303 triangles that are now pulled in by the earthworms. Okay. So, there is 303 earthworms in that field, each one has pulled in one. What is the data saying? Which end is being pulled? This is a classical null hypothesis game. The null hypothesis says, damn it, I am. Okay. But if you are going strictly by the chance, you are going to have 5:1, all that ratio depending upon what. And third is an equally likely one, 33%, 33.3, 33.3, 33.3. Fourth one is none of the above. So, 303 he retrieved from both the broad and the narrow triangles. 59% are pulled in by their narrow end, apical end, while about I think 12 or 13% is from their bottom end, completely rejecting the null hypothesis, completely rejecting the hypothesis that these are picked by random chance events. They, if anything, completely non-random from the probability estimates that you made in the previous slide. Same is true for the narrow triangles. 5% of the cardboard triangles are picked from their apical end, while the rest is from the middle and bottom end. In either case, it demolishes the assumption that earthworms are doing the job by just chance. No, it seems there is something more than chance to these earthworms in pulling leaves, or in this case cardboard triangles, into their burrows. Isn't it great? He says, we may therefore conclude that the manner in which the triangles are drawn into burrows is not a matter of chance. We all have to believe in that, right? Are you guys impressed by this data? and by the way he did this experiment and derived, it's just QED, nothing more, nothing less. So, this final experiment, when I first read this experiment, I was absolutely floored for various reasons. One, of course, is I never knew that Darwin was a cont man. If anything, he is a verbose man. He probably hasn't used an equation in his life. And all these last few experiments belies the fact, how could he now do all of this, isn't it, number crunching, and forget number crunching, even the analysis that required such complex in those days, it was apparently very complex to think in this sort of term and write so lucidly about that. So, the final experiment, the triangle experiment, raises lots of issues. If anything, this shows that he was an astute mathematician. This probably could be the origins of rigorous statistical testing and analysis, which was not at all advanced in his days. Remember, all of you, that much of statistics grew up in the late 1880s or 90s, just about the time when this guy had written his book. And all your contingency chi-squares and all followed later, and of course, it was the early 1920s that Ronald Fisher came into being, and we had lots and lots of statistics. So, whatever you are looking at Darwin predates the, I would say, even the advancements of the infant stages of statistics. Last of all, in the field of behavioral studies, whatever he did can compare to the best that you see today in the behavioral ecological work in terms of the stats that he employed. So, these capabilities of Darwin, least to say, were puzzling and have surprised many, including me. How did he do it? Did he seek some help, and so on and so forth. So, I have been trying for last few years to now ask if he actually sought help, like if we are all, I suppose we are all biologists, if you have a tough statistical questions, you run up to a statistician to help you out. Why it is puzzling and surprising? If anything, Darwin seemed to be a very reluctant mathematician. He said that it was repugnant to me to think of maths. It was known that Francis Galton was Charles Darwin's cousin. They shared the great grandfather. But Francis Galton was a tremendous personality, and some of you may have heard of Francis Galton. He was knighted Sir Francis Galton. Who is Sir Francis Galton? Now, this guy is the guy who coined the word eugenics. Some of you would have done Pearson moment correlation. Now, Pearson was Galton's student. He contributed to the idea of correlation regression. He founded the field of psychometrics, which is even today in vogue. He developed the first climate maps of the world. The United States was the first country to develop fingerprints, and Sir Francis Galton helped those guys develop unique identity based on the fingerprints. He invented the Galton whistle for hearing disability. So, this is the guy. Now, where is the connection to Charles Darwin? I have tried my best over the last few years, going to various libraries, googling the information and all that. I got just one piece of evidence, and that is a letter transacted between Charles Darwin and Francis Galton in March 8, 1881. Now, if you just recall, 10th October 1881 was the publication. He is towards doing all these experiments and finalizing. So, he writes on March 8, 1881 to Francis Galton, and he writes here, I have tried drawing triangles of damp paper through a small cylindrical hole as you suggested, and I can discover no source of error. So, that is the only line I could scavenge out of the correspondence between Galton and Darwin. It appears, I am not taking away the credit from Charles Darwin, but I was having the hunch that he might have talked with, because they were contemporary in terms of the time period. So, he might have sought some help, but it appears he did discuss this issue with Francis Galton, and it still remains as a historical piece of research if there was more than just a passing mention of his work on earthworms to Francis Galton. And apparently from the sentence, as you suggested, it appears they may have discussed something. I do not know how much and what. Darwin, as I mentioned, he was a reluctant mathematician. He abhorred mathematics, but in his autobiography, he writes of his youthful distaste for math. He also wrote that he wished he had learned the basic principle of math, for men thus endowed seem to have an extra sense. All of you will agree. So, coming back to worms, after all said and done, what is the take home? He says one alternative alone is left, namely that worms, although standing low in the scale of organization, possess some degree of intelligence. Now, this really sort of stoked the fire in people there. Please remember, this is the Victorian era. Okay? Only the royal family were given all these concessions, the subjects no. And how could then even earthworms have, you can even speak of earthworms having some degree of intelligence. But he says, for those who were critical, this will strike everyone as very improbable, but it may be doubted whether we know enough about the nervous system of the lower animals to justify our natural distrust of such a conclusion. And with this, he sort of left behind, I would say, a legacy of work, thought, and all sorts of things for people to now ponder about. Thank you.